In this video for section 8.2, we're going to talk about a special type of sequence called an arithmetic sequence. In an arithmetic sequence, each term differs from the next by a constant amount. This amount is called the common difference. Another way to think of it is that you are adding or subtracting the same amount to each term to get the next term. That common difference is often labeled with the letter D. So we're going to look at example 1. It says to write the first 6 terms of the arithmetic sequence in which a1 equals 6 and a sub n equals a sub n minus 1 minus 2. Now remember that a sub n minus 1 stands for the previous term. So to get the next term in my sequence, I take the previous term and I subtract 2. So my first term is 6. That's given to me. My second term would be 6 minus 2, which is 4. My third term would be 4 minus 2, which is 2. My fourth term would be 2 minus 2, which is 0. My fifth term would be 0 minus 2, which is negative 2. And my sixth term would be negative 2 minus 2, which is negative 4. So as you can see, as I go from one term to the next, the value of the term is decreasing by 2. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer, and then move on with the video. Next, we're going to look at a formula for the general term of an arithmetic sequence. The formula is a sub n equals a sub 1 plus n minus 1 times d. So for example 2, we want to find the 8th term of the arithmetic sequence whose first term is 4 and whose common difference is negative 7. So the 8th term means that n equals 8. My first term, a1, is 4. And the value of d is negative 7. So all I need to do is plug into the general form and I can get the value for the 8th term. So the advantage here is that I don't need to find all of the terms before the 8th term. I could do this the long way and say, okay, the first term is 4. I could subtract 7 to get the second term, subtract 7 again to get the third term, all the way up to 8. That would be a valid way to do the problem, but using the formula for the general term is going to be faster, especially if your value for the term number you're looking for is much higher than 8. So a sub 8 equals a sub 1 is 4 plus n minus 1 is 8 minus 1 times d, which is negative 7. So now this is just a little bit of math to do. You can type this all into your calculator or say that 8 minus 1 is 7. Then I multiply 7 by negative 7. Make sure that you do the correct order of operations. That's negative 49. And negative 49 plus 4 is negative 45. So a sub 8, the 8th term of the sequence, is negative 45. So now you should look at checkpoint problem number 2. Do this in your notes, check your answer, and then move on with the video. In example 3, we're asked to write a formula for the general term of the given arithmetic sequence. So we have our sequence values here, negative 2, 8, 18, and 28. To write a formula for the general term, we need to identify our first term, a sub 1, this is negative 2, and the common difference. To identify what the common difference is, I need to look at what number am I adding or subtracting each time to get the next term. And I can pretty easily see that I'm adding or subtracting 10 to each term to get the next. So my common difference, d, is 10. Now when I write the formula for the general term, n is going to be a variable. So I'm going to leave n as n. So a sub n equals a sub 1 negative 2 plus n minus 1 times d. So I'm going to leave n as n minus 1 times d, which is 10. Now it's a little bit strange because they write the value for d after the n minus 1 set of parentheses. I'm not really sure why, but you're going to distribute that 10 into the parentheses, even though it's not in front like we usually would see it. So we have negative 2 plus 10n minus 10. And then lastly, combine the like terms of negative 2 and negative 10. That gives me 10n minus 12, or negative 12 plus 10n. You could write it that way as well. So this is my formula for the general term. So if I want to find any term number in this sequence, I would just plug in the value for the term number I want, and this would give me the value. So for example, to find the second term, plug in 2 for n. 10 times 2 is 20. 20 minus 12 is 8. So the second term is 8. So next you should look at checkpoint problem number 3. Do this in your notes, check your answer, and then move on with the video. Our last formula here is for the sum of the first n terms of an arithmetic sequence. So this formula has S sub n, which stands for sum, equals n divided by 2 times a1 plus a sub n. So in example 5, we're asked to find the sum of the first 100 terms of the arithmetic sequence, 1, 3, 5, 7, etc. So I want to find the sum of the first 100 terms, which means that n is 100. And I can pretty easily identify my first term, a sub 1 is 1. Now, in order to use this formula, I need to know the value of the 100th term, a sub 100. Now, I could go through this and add 2 each time until I get 100 terms. That would take a very long time. It's easier if I use the general term, which we saw the formula above. So we're going to use this formula first before we use our sum formula. So this problem is a little bit more complicated because we actually have to use both formulas here. So I need to find a sub 100, which is a sub 1 plus n minus 1 times d. So I'll write that here to remind myself. I know what a sub 1 is. I know what n is. What is d? Well, if I look at this, what number am I adding each time to get the next term? Well, that's going to be 2. I'm adding 2 each time. So the value of d is 2. So a sub 100 is 1 plus, because a sub 1 is 1, 100 minus 1 times 2. 100 minus 1 is 99. Oops. So it's 1 plus 99 times 2, which is 1 plus 198, which is 199. So that's my 100th term. So now I'm going to plug into the sum formula. N is 100 divided by 2, parentheses, a sub 1 is 1, a sub 100 is 199, and then just do the math. You can type this into a calculator or do it by hand. 100 divided by 2 is 50, 1 plus 199 is 200, and 50 times 200 is 10,000. So that's my answer, 10,000. So next you should look at checkpoint number 5. Do this in your notes, check your answer, and then move on to the homework.